Today we are going to talk about factors and greatest common factor. Hopefully this is something you guys have heard before. This should be a review lesson. I know when I taught 5th grade that I taught on greatest common factor as well as factors, but I am also hoping that maybe I'm going to show you a different, maybe easier way to find common factors than when you were in elementary school. So let's start by getting out our math spirals and opening to a new blank page. And at the top of the page, we're going to go ahead and write the title of today's lesson, Greatest Common Factor. When you're done, put your pencils down so that we know that you are done and ready to move on to the next slide. Let's go ahead and do that now. So just as a reminder, your pencil should not be in your hand and you should not be writing while I am explaining the slides. At the end of the explanation, I will pause the video and you will be allowed to copy the slide into your notes at that point. So everybody's pencils should be down and we should be listening to the explanation of the slide. So let's start with the definition of a factor. A factor is a number that is being multiplied to get a product. So if you have a multiplication fact like 2 times 6 equals 12, the factors are the numbers you're multiplying, 2 and 6, and your product is your answer to your multiplication fact. So when you are finding the factors of 12, you are looking for all of the numbers that you can multiply to get 12. So we have 1 times 12, 2 times 6, and 3 times 4. Those are all of the factors of 12. When I taught elementary school, you were always told to put your factors in order least to greatest. So after you find all of your factors, then you have to make a list. 1, 2, 3, 4, 6, and 12. And I know that some teachers show the rainbow method where they connect those factor pairs so that you know you have all of your factors. So 1 times 12, 2 times 6, and 3 times 4. These are all strategies that you may have seen in the past, and you are welcome to use any of them in my classroom. One of the problems that I see in middle school is when we do larger numbers and we find factors of larger numbers, a lot of my students miss some of their factors. They also don't always know their multiplication facts, and that causes them to struggle. So I'm going to show you some tips and tricks that will help you get all of your factors. So before we look at some more examples, I want you to pause the video and copy this slide into your notes. Please pause the video now. One of the hardest things about finding factors in 6th grade is a lot of our numbers are very large numbers, and you can't use basic facts. Even if you know your multiplication facts, a lot of times the numbers are much larger than our multiplication facts that we memorized in elementary school. And a lot of you still struggle with your multiplication facts from elementary school. So what happens is you end up missing one factor pair. Unfortunately, in math, our answers are never close. They're either right or wrong. If you're missing one factor pair, your answer is wrong. So you have to make sure that you get all of the factor pairs. So here is something that I've always shown my students that really helps them to make sure they get all of the factor pairs. We can use 2 things. 1, we can use our divisibility rules. 2, we can use our calculators and our fact families. So start by making a T-table and putting the number that you are trying to find the factors for at the top of the T-table. So the first example that we are going to do together is we are going to find the factors of 132. So I'm going to put 132 at the top of the T table. Then on the left side of the T table, I'm going to list all of my numbers 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We all know that every number has a factor of 1 and itself, because we can always multiply 1 times itself to get that number. So my first factor pair is 1 and 132. Then, using my divisibility rules, I can determine if it's divisible by 2. Remember, if the number is even, it's divisible by 2. 132 is an even number, so it's divisible by 2. If it's divisible by 2, then 2 is a factor of 132. I don't know 2 times what equals 132. So I can use my fact family. I can use division and my calculator. Starting with 132, divide by 2, my answer is 66. That means 2 times 66 equals 132. So my next factor pair is 2 and 66. The divisibility rule for 3 is adding all of the digits in your number. If the sum of the digits is divisible by 3, then the number is divisible by 3. Let's add the digits in 132. 1 plus 3 is 4. Plus 2 is 6. 6 is divisible by 3. So 132 is divisible by 3. But I don't know 3 times what is 132. So I can use my fact family. 132 divided by 3 equals 44. So my next factor pair is 3 and 44. The divisibility rule for 4 is if the last 2 digits are divisible by 4, the whole number is divisible by 4. The last 2 digits in 132 are 32. 4 times 8 is 32. So 132 is divisible by 4. 132 divided by 4 equals 33. So 4 times 33 is 132. That is my next factor pair. The divisibility rule for 5 is your number has to end in 0 or 5 for it to be divisible by 5. 132 ends in 2. Not 0 or 5. So it's not divisible by 5. 5 is not a factor of 132. So I'm going to squiggle it out because that is not one of my factors. The divisibility rule for 6 is if 2 and 3 are factors, so is 6, because 2 times 3 is 6. 2 and 3 are both factors, so is 6. 132 divided by 6 equals 22. So my next factor pair is 6 and 22. I don't have a divisibility rule for 7, so I'm just going to check it in my calculator. 132 divided by 7 equals, oh my goodness, that is a long decimal. Remember, if you have a decimal, you have a remainder. If you have a remainder, it's not divisible. If it is not divisible by 7, then 7 is not a factor. So I am going to squiggle out 7. 132 divided by 8. You also have a decimal. So 132 is not divisible by 8, and 8 is not a factor. 132 divided by 9. Again, we have a decimal. That means that 132 is not divisible by 9, and 9 is not a factor. Our divisibility rule for 10 is our number has to end in 0 or 5. 132 ends in 2, so it is not a factor. 132 divided by 11 equals 12. When you get an answer that is less than the numbers on the left side or starts to repeat a number on the left side, like 12, that's how we know we have all of our factor pairs. The cool thing is, if you look at your T-chart and you start on the left and you go around in a loop, you already have the numbers there, least to greatest. So it's very easy to create our list. The factors of 132 are 1, 2, 3, 4, 6, 11, 12, 22, 33, 44, 66, and 132. We are going to do one more example together. Before we do that example, let's go ahead and pause the video and get this first example copied into your notes. Please pause the video now. Let's try one more example together. Let's find all of the factors of 140. So remember, the first step is to put 140 at the top of your T table and then list all of the numbers 1 to 12 on the left side. I always know that my number and 1 is a factor pair. So my first factor pair is 140 and 1. 140 is an even number, so it is a factor of 2. So let's use our calculator and do 140 divided by 2 to find the other factor. So 2 and 70 are my next factor pair. If I add my digits, 1 plus 4 plus 0, I get 5. 5 is not divisible by 3, so 140 is not divisible by 3, and 3 is not a factor. My last two digits are 40. 40 is divisible by 4, so 140 is also divisible by 4. Use your calculator. 140 divided by 4 equals 35. 140 ends in 0, so it's divisible by 5. 140 divided by 5 equals 28. So my next factor pair is 5 and 28. In order for 6 to be a factor, 2 and 3 also have to be a factor. 3 is not a factor, so 6 is not a factor. 140 divided by 7 equals 20. So my next factor pair is 7 and 20. 140 divided by 8 equals 17 and 5/10. If there's a decimal, it's not a factor. So 8 is not a factor of 140. 140 divided by 9 equals, again, we get a decimal. If there is a decimal, it is not a factor. So 9 is not a factor of 140. If your number ends in 0, it's divisible by 10. So 10 is a factor of 140. 140 divided by 10 equals 14. 140 divided by 11 equals, nope, not a factor. 140 divided by 12 equals, 11 is smaller. Remember, when your answer is smaller than the number on your left side, you have all of your factor pairs. 11 and 6/10 over and over and over, that's called repeating, is smaller than 12. So I know that I have all of my factor pairs. Again, when we put them in order, we just go in a loop around our T table. So all of our factors of 140 are 1, 2, 4, 5, 7, 10, 14, 20, 28, 35, 70, and 140. Pause the video and copy this second example into your notes. Then we will try some problems on our desk together. Pause the video now. Let's try some problems together on our desk. Get your SOC and Expo markers out of the boxes on your table. Do not close your notes. These are the first problems that we are practicing together. You might need to look back at the examples that we did earlier if you get stuck. Just put your notes on the side of your table so you have space to try some problems on your own. Let's start with a number that's not as big as the examples that we did first. So let's try to find all of the factors of, let's do 72. Create your T-table on your desk. Remember, it takes a lot of time to find all of the factors and go through all of your numbers. Please take your time. We will do as many practice problems as we have time for. When the majority of you are finished, we will play the video and I will go through all of the factor pairs with you. Pause the video and try number 72 on your desk now. The first factor pair of 72 is 1 and 72. 72 is even, so 72 divided by 2 is 36. The next factor pair is 2 and 36. 7 plus 2 is 9. 9 is divisible by 3, so is 72. 72 divided by 3 is 24. Our next factor pair is 24. 72 divided by 4 is 18. Our next factor pair is 18. 72 does not end in 0 or 5, so it is not divisible by 5. 72 divided by 6 is 12, so our next factor pair is 6 and 12. 72 divided by 7 is a decimal, so 7 is not a factor of 72. 72 divided by 8 is 9. We have the same number on the left and right side. That means that we have all of our factor pairs and we don't have to continue with 9, 10, 11, or 12. Remember, when the number on the right-hand side is smaller than the numbers on the left, you have all of your factor pairs. So here we have an order, least to greatest, of all of our factor pairs. The factor pairs of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Let's try another problem on our desks together. Let's find all of the factor pairs of 104. Pause the video now and try this problem on your desk. The first factor pair is 104 and 1. 104 is even, so it is divisible by 2. 104 divided by 2 is 52. So my next factor pair is 52. 4 plus 0 plus 1 is 5. 5 is not divisible by 3. So 104 is also not divisible by 3. It gives us a decimal. So 3 is not a factor of 104. 104 divided by 4 is 26. So my next factor pair is 26. 104 does not end in 5 or 0, so it is not a factor of 5. 104 divided by 6 gives us a decimal, so 6 is not a factor of 104. 104 divided by 7 is a decimal, so it is not a factor of 104. 104 divided by 8 is 13. 104 divided by 9 is a decimal, so it is not a factor of 104. 104 divided by 10 is a decimal. Its whole number is also equal to the whole number on the left side, which means we do not have to continue with 11 or 12. We have found all of our factors of 104. In order, least to greatest, our factors of 104 are 1, 2, 4, 8, 13, 26, 52, and 104. I hope you guys are doing a fantastic job. Let's try another problem together. This time, let's find all of the factors of 120. Pause the video and try this problem on your desk. Our first factor pair is 1 and 120. 120 is even, so our next factor pair is 2 and 60. 1 plus 2 is 3, plus 0 is 3. 3 is divisible by 3, so 120 is also divisible by 3. 3 and 40 is our next factor pair. 120 divided by 4 is 30. 4 and 30 is our next factor pair. This number ends in a 0, so 120 divided by 5 is 24. 5 and 24 is our next factor pair. 120 divided by 6 is 20, so 6 and 20 is our next factor pair. 120 divided by 7 is a decimal, so 7 is not a factor of 120. 120 divided by 8 is 15, so 8 and 15 is our next factor pair. 120 divided by 9 is a decimal, so 9 is not a factor of 120. 120 divided by 10 is 12, so my next factor pair is 12. We have 12 on this side and this side. We are not done until we try 11. 120 divided by 11 is 10 and a decimal, so this is not a factor pair. So we are done with our list of factors for 120. There are a lot of factors for 120. 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. Wow, that's a lot of factors. Let's try one more problem on our desk together. Let's find the factors of 93. Pause the video and find all of the factors of 93. The first factor of 93 is 1 and 93. 93 is odd, so 2 is not a factor of 93. 9 plus 3 is 12. 12 is divisible by 3, so is 93. 93 divided by 3 is 31. So my next factor pair is 3 and 31. 93 divided by 4 is a decimal, so 4 is not a factor of 93. 93 does not end in 5 or 0, so 5 is not a factor of 93. Remember, in order for 6 to be a factor, you have to have 2 and 3. 2 is not a factor, so 6 is not a factor. 93 divided by 7 is a decimal, so 7 is not a factor. 93 divided by 8 is a decimal, So 8 is not a factor. 93 divided by 9 is a decimal. So 9 is not a factor. 93 divided by 10 is a decimal. So 10 is not a factor. 9.3 is less than 11. That means I have all of my factors of 93, and I can stop there. There are only 4 factors of 93. 1, 3, 31, and 93. Hopefully, this method will help you make sure that you are never missing a factor pair. We will continue to practice factors more tomorrow, and then we will continue with this lesson and add to our notes on the same page as factors, greatest common factors. This is the end of the first part of this lesson. Please stop the video and pick up here when we resume this lesson. Now that we have learned what a factor is, today we will talk about common factors and greatest common factors. These notes should be included in the lesson on factors. You do not need to start a new page in your math spirals or give it a new heading. Please open your math spirals to the page that we were writing our notes on factors in. When a number shares a factor, these are called common factors. The word common means the same. So whenever you think of common factors, you should think about factors that are the same. So if I have the number 12 and the number 14, the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 14 are 1, 2, 7, and 14. Notice that both 12 and 14 have the same factor 1 and 2. These are both called common factors because it's the same factor for both numbers. The largest of the common factors is called the greatest common factor. So if you have more than one factor that's the same between two numbers, the largest of those same factors is your greatest common factor, or GCF as an abbreviation. Go ahead and pause the video and copy this slide into your notes. There are 2 ways to find the common factors and the greatest common factor. Many of you probably have learned this in elementary school already. You may not remember all of it, but you are probably thinking as I'm teaching, oh yeah, I remember this. We learned this. The traditional way is to make a list of all of the factors of each number that you are given, like we learned in the previous lesson. Here I have a T-table of all of my factors of 24. And here I put them in order, least to greatest. Here I have a T-table that has all of my factors of 36. And here I made a list, putting all of them in order, least to greatest. So step 1 that you were probably taught in elementary school is to list the factors for both numbers. Then you go through and circle all of the common factors. Here I have all of the common factors in red. So my common factors are 1, 2, 3, 4, 6, and 12. There are 1, 2, 3, 4, 5, 6 factors that are the same between the numbers 24 and 36. Once you know all of the common factors, you simply find the largest of the common factors, and that number is your GCF. So here is the list of my common factors. So my greatest common factor is 12. This way works, but it takes a lot of time. And it is often one where my students make mistakes because they will forget or miss one of their factors. I am going to show you a different way today that you may or may not have seen before that I think is more effective in helping you find the common factor without having to make a list of all of the factors first. Before we look at the new way, let's copy this example and the steps for finding the greatest common factor into your notes. Pause the video and copy this into your notes now. The other way that you can use to find the GCF is called the ladder method, or the upside down cake, because it looks like steps of a ladder or tiers on a cake, but it kind of looks upside down. So whichever way helps you remember it, it doesn't really matter. What matters is how we use it. So here we have an example that we're going to look at together. We are going to use the ladder method to find the GCF of 48 and 72. So my first step is to write both of the numbers that I'm going to find the GCF for. So here I have 48 and 72. And I am going to put a box around those numbers. Then you're going to think of a number that you can divide both of those numbers by. You don't have to think of the largest number. Use your divisibility rules. I always start with 2 if they're both even. Both of these numbers are even, so I know that they can be divided by 2. So you're going to put the number that you're dividing by outside the box, and then you're going to divide both of those numbers by 2. So 48 divided by 2 is 24. And you're going to put the number underneath of 48. 72 divided by 2 is 36. And you're going to put another box around both of those numbers. Notice that the box is a little bit smaller. That's because we've made the numbers smaller. You see how it kind of looks like tiers of a cake upside down or steps on a ladder? So we're going to do this again. We're going to think of a number that you can divide both 24 and 36 by. Again, don't make it any harder than it is. They're both even, so I can divide both of them by 2. So I'm going to put the 2 outside, and I'm going to divide 24 by 2, and I'm going to put it underneath. And I'm going to divide 36 by 2, and I'm going to put it underneath. Put a box around your numbers. You continue to do this until you can't divide anymore. So again, 12 and 18 are both even numbers. So we can divide them by 2. 12 divided by 2 equals 6. 18 divided by 2 equals 9. A lot of times my students stop here because they're not both even numbers. But be careful, because you can still divide 6 and 9. You just can't divide by 2. You can divide by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. Now you can't divide anymore. So my students say, but where's the greatest common factor, Ms. Dunn? If you look at all of these numbers, that you divided by and you multiply them out, it will give you the GCF. So to find the GCF of 48 and 72, we are going to multiply 2 times 2 times 2 times 3. 2 times 2 is 4. 2 times 3 is 6. 4 times 6 is 24. So the GCF of 48 and 72 is 24. And remember, it's a factor of 48 and 72, meaning your GCF, you should be able to divide both the 48 and 72 by your GCF. So let's just check and make sure we did it right. 48 divided by 24 is 2. So 2 times 24 is 48. 24 is a factor of 48. 72 divided by 24 is 3. So 24 times 3 is 72. 24 is a factor of 72. So the GCF of 48 and 72 is 24. This is such a great way of finding the GCF. We will look at several examples of this. I know that this method is new to many of you, but it is fun and easy way to find GCF. Before we look at another example, please pause the video and copy this first example into your notes. Please pause the video now. Let's do another example of GCF using the ladder method. This time, we are going to find the GCF of 24 and 108. So we start by putting 24 and 108 in a box. Again, both of my numbers are even, so we can divide both 24 and 108 by 2. 24 divided by 2 is 12. 108 divided by 2 is 54. Put the 2 outside the box, put 12 and 54 under the box, and put it in a box. 12 and 54 are both even, so they can be divided by 2 again. Put your 2 outside. 12 divided by 2 is 6. Put your answer underneath. 54 divided by 2 is 27. Put your answer underneath. These are not both even. Typically, if I can't divide by 2, I try 3 next. If I can't divide by 3, I try 5. Using your prime numbers is usually the best way to go. We can usually divide by 2, 3, 5, or 7. So here I can divide both 6 and 27 by 3. 6 divided by 3 is 2. 27 divided by 3 is 9. There is nothing that we can divide 2 and 9 by. So this is our final answer. Well, not really our final answer, because we still have to multiply all of the numbers that we divided by to find our GCF. So to find the GCF of 24 and 108, we have to multiply 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So my GCF of 24 and 108 is 12. Let's divide to make sure that they really are factors. 24 divided by 12 is 2. So 12 times 2 is 24, and 12 is a factor of 24. 108 divided by 12 is 9. So 12 times 9 is 108, and 12 is a factor of 108. So my GCF of 24 and 108 is 12. Pause the video and copy this second example into your notes now. cool thing about the ladder method is it can be used to find the GCF of more than two numbers very easily. It works and can be applied no matter how many numbers you're trying to find the GCF for. So here's an example of three numbers. Let's use the ladder method to find the GCF for all three numbers. The steps are still the same. You start by putting all three numbers in a box. So we have 12, 18, and 60. All three of those numbers are even. So I'm going to divide all of them by 2. 12 divided by 2 is 6. 18 divided by 2 is 9. And 60 divided by 2 is 30. All three of those numbers cannot be divided by 2, but they can be divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 30 divided by 3 is 10. Two of those numbers can be divided by 2, but not all three. If they can't all three be divided by the same number, then we are done. So to find the GCF, we have to multiply the two numbers that we divided by. So to find the GCF of 12, 18, and 60, we are going to multiply 2 times 3. The GCF of 12, 18, and 60 is 6. We can divide all three numbers by 6 to make sure that they are factors. 18 divided by 6 is 3, and 60 divided by 6 is 10. So 12, 18, and 60 all have a factor of 6, and 6 is the GCF. Pause the video and copy this example into your notes. Then we are going to try some problems together on our desk. Pause the video now. When you are completing this assignment for a grade, I do not mind if you use the traditional way or the ladder method for finding the GCF, whichever way you prefer. However, as we practice these on our desk today, I would like for everybody to try the ladder method. The ladder method is probably the new way for most of you. And a lot of us don't like new or different. We like to do things the way we already know how to do. But I believe the ladder method will be better and easier for you, and many of you will get it correct more often. So to try it in a safe place when it's not for a grade, I would like everybody to try the ladder method as we practice these problems today. Please get out a sock and an expo marker. Do not close your notes. We are practicing for the first time. You may forget the steps and you may need to look in your notes for an example. Please pause the video and try number 1 on your desk. Let's look at number 1 together. Number 1 is kind of a tricky one to get us started because both 18 and 27 cannot be divided by 2. But remember, if 2 doesn't work, usually 3 does. 18 divided by 3 is 6, and 27 divided by 3 is 9. And then we can divide by 3 again. 6 divided by 3 is 2. 9 divided by 3 is 3. So the GCF of 18 and 27 is 3 times 3, which is 9. Hopefully you guys got the hang of that. If not, and you got stuck, hopefully you see from Miss Dunn working it out where you got stuck. Let's pause the video and try number 2 on our desk now. For number 2, both 32 and 72 are even. So we can divide both of them by 2. 32 divided by 2 is 16. 72 divided by 2 is 36. Both of those numbers are still even. So we can divide by 2 again. 16 divided by 2 is 8. 36 divided by 2 is 18. Still, both of those numbers are even, so we can divide by 2 again. 8 divided by 2 is 4. 18 divided by 2 is 9. 4 can be divided by 2, but 9 cannot. 9 can be divided by 3, but 4 cannot. That means we are done. So to find our GCF of 32 and 72, we are going to multiply 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So our GCF of 32 and 72 is 8. Let's pause the video and try to find a GCF of 3 numbers. Let's try number 3 on our desk. Find the GCF of 21, 42, and 56. Pause the video now. So let's look at number 3 together. Let's start by putting all 3 numbers in a box. 21, 42, and 56. Again, all 3 of these numbers are not even. So we cannot divide by 2. 21 divided by 3, yep. 42 divided by 3, yep. 56 divided by 3. Oh no, so 3 doesn't work. 5 doesn't work because they don't end in 0 or 5. So remember what I said, always start with your prime numbers. This is the hardest one. In order to figure out this one, you have to start by dividing by the prime number 7. 21 divided by 7 is 3. 42 divided by 7 is 6. 56 divided by 7 is 8. And then there's nothing else that you can divide by. So the GCF of these 3 numbers is 7. That was a really tricky problem. Hopefully, you guys got that one. If you did, give yourself a pat on the back. Great job. Let's try another one that has 3 numbers in it. Pause the video and try number 4 on your desk. Number 4 is also a little bit tricky, but not as tricky as number 3. You cannot divide all 3 numbers by 2, but all 3 numbers have a 5 or a 0 in the ones place. That means if you think about your divisibility rules, that all 3 numbers can be divided by 5. 15 divided by 5 is 3. 30 divided by 5 is 6. And 60 divided by 5 is 12. We are not done because all 3 of those numbers can also be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 12 divided by 3 is 4. Now we are done. So the GCF of 15, 30, and 60 is 5 times 3, which is 15. We have 2 more problems to practice together today. Go ahead and pause the video and try number 5 on your desk. 18, 24, and 36 are all even numbers. They can all be divided by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. 36 divided by 2 is 18. 9, 12, and 18 can all be divided by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 18 divided by 3 is 6. 4 and 6 can both be divided by 2. 3 and 6 can both be divided by 3. But there is no number that all three numbers can be divided by. So this is the end of our dividing. So our GCF is 2 times 3, which is 6. So the GCF of 18, 24, and 36 is 6. We have one more problem to try on our desk today. Please pause the video and try number 6 on your desk. 9, 36, and 81 can all be divided by 3. 9 divided by 3 is 3. 36 divided by 3 is 12. 81 divided by 3 is 27. 3, 12, and 27 can all be divided by 3 again. 3 divided by 3 is 1. 12 divided by 3 is 4. 27 divided by 3 is 9. The GCF of 9, 36, and 81 is 3 times 3, which is 9. The GCF is 9. Hopefully you guys are all becoming used to the ladder method and you like it as much as I do. I find this method to be a lot more easier and a lot more fun than the list method. Tomorrow, you will practice finding the GCF more. I hope you guys are all doing well, and I will see you soon. Have a great rest of your day.